David.
David, give me one of the derivative rules that you know for sure.
Product rule.
Product rule. What's the product rule? What is right?
Y prime equals f prime of x times g of x plus f of x times g prime of x.
Wow. All right. Next. Andrew, who's next?
Celeste.
Celeste. Pick one. Which one you want?
First one.
First one. Power rule.
N x to the power of n minus 1.
N times x to the n minus 1. Nice. Andrew.
Palamon.
Palamon. Pick one.
Special case 1.
Special case 1. Derivative of the square root of x, you know, automatically is 1/2 x to the negative 1/2. That's one way to write it. The other way, the better way to write it is 1 over 2 square roots of x. Nice job. Incoming. Next. Luis.
Extended product rule.
Extended product rule. Go for it.
F prime of x times g of x times h of x plus f of x times prime of g of x times h of x plus f of x times g of x times prime of h of x.
Okay, and I totally got lazy. I stopped writing my of x, f prime gh plus f g prime h plus f g h prime. Next. Andrew. Next. Steven.
Derivative of a constant.
Derivative of a constant. What a brave man you are. What's the derivative of a constant?
1.
What?
0.
See? Your brain needs rest. Writing your English paper at 1:30 in the morning on Sunday, not good. All right, next, Andrew. Ile.
Special case 2.
Special case 2. Derivative of 1 over x. You know this to be?
Negative 1 over x squared.
Negative 1 over x squared. Nice job. Andrew, next.
Aaron.
Didn't even try to catch it. Next.
Aaron.
Aaron.
Quotient rule number 2.
Quotient rule. Give me the quotient rule.
G of x times f prime of x
G of x times f prime of x.
minus. Oh, still right. F of x times g prime of x
Yeah.
over g of x squared.
Over g of x, the whole thing squared. Love it. Next.
Carmen.
Carmen.
Chain rule.
Chain rule. Okay, all the way down here.
F prime of g of x times g prime of x.
F prime of g of x times g prime of x. Sorry, I couldn't get it to fit on the paper. Carmen, here you go. And Carmen, you did a great job at the poster. Here you go too. All right, next.
Myra.
Myra.
6.
6. The sum rule.
Y prime equals f prime of x plus g prime of x.
F prime of x plus g prime of x. Nice job. Andrew, next.
Giselle.
Giselle. You don't know any other? Okay. How about the difference rule? The sum rule says if I'm adding two functions together, take the derivative of the first, derivative of the second, add them together. So the difference rule? F prime of x minus g prime of x. Nice job. Incoming. Andrew.
The fourth.
The fourth one, and is there a number 13?
12. No,
12.
12 is f prime of g of h of x
F prime of g of h of x
times g prime of h of x.
Yep.
And then times prime h.
Times h prime of x. Nice job, Andrew. And Louis, what did you think I was throwing? All right, and North Central.
0.
Okay, awkward. Constant multiple rule. If you have a constant times a function, the way that you take the derivative, you leave the constant alone times the derivative of the function. That's that. Right? Like, for example, what's the derivative of x squared? Oh my gosh. The derivative of x squared is 2x. What if I multiplied the original function by a constant like 5? The derivative of 5 times x squared is 5 times the derivative of x squared, which is where you're going to get 10x from. I think what normally happens, for some reason, these 4 over here that you guys know instinctively, in the brain it's like, ah, short circuit. What do you mean the constant multiple rule? I mean you take the derivative of the function and you leave the constant alone. But the derivative of a constant not attached to a function is just 0, not Not one. No one would ever say one. He's not even listening to me, okay? All right. So that's... Never mind me, Hope, back then. All right. So that is 12 of the derivative rules. If all goes well today, we're going to pick up 1, 2, 3, 4, 5, 6 more. 6. What?
I thought you said 5.
I have high expectations. Today it's 6. All right. So one of the functions that you don't know how to find the derivative of is the natural log of x. We just don't know how to find the derivative of the natural log of x, and sad news, although some folks are like, oh, I know, if f of x is the natural log of x, they want to use the product rule for some reason.
What?
I'm saying, I have seen it out there on the streets. It's bad. Some people look at f of x as the natural log of x, and they're like, oh, this means natural log times x.
But how?
No.
How does that mean that?
It doesn't even make sense. So instead, I want to go through the process. We've played this game before. Here's the graph of f. I want you to tell me what must be true about the derivative of f of x. So for example, when I look at the graph of f of x, I know for the natural log of x that the f of x has a vertical asymptote. F of x has a vertical asymptote at x equals 0. So what has to be true about f prime? Think about all those derivative relationships. If this guy has a vertical asymptote, the derivative has to have a vertical asymptote as well. So f prime of x has a vertical asymptote at x equals 0. That's true, because we know when it comes to functions, once you have a vertical asymptote, it stays with you forever. Other things that I could say about the graph of f of x? Yeah, Lewis.
It's increasing the whole.
What?
F of x is increasing the whole.
F of x is increasing when?
From 0 to infinity.
Okay, I'm going to say like on the interval 0 to infinity. So if the graph of f of x is increasing on the interval 0 to infinity, then what am I suspecting about the derivative? F prime has to be positive. So f prime of x is greater than 0 on the interval 0 to infinity. Okay, that's good. So I'm going to be above the x-axis. Anybody else see anything else about f of x equals the natural log of x? What was that, Paulo? The slope is decreasing. Is that true? Are the slopes decreasing?
Yes.
They seem to be getting, right, they're positive, but they're getting less positive. True. What else?
It has f of x has a horizontal asymptote.
F of x has a horizontal asymptote is actually not
Always increasing.
the graph. Relax. It's one time. Okay? Alright. The graph of the natural log of x increases forever without having a horizontal asymptote. But it increases slowly. Remember we used to call it like the slog function? It increases so slowly. You think it has a horizontal asymptote, but it doesn't. No one's mentioned anything about concavity. Carmen, save yourself here.
F of x is concave down.
F of x is concave down. Where?
On the interval 0 to infinity.
So if f of x is concave down in the interval 0 to infinity, then what do I know about f prime?
F prime is decreasing.
F prime is decreasing
On the interval 0 to infinity.
on the interval 0 to infinity. So I need my derivative to have a vertical asymptote. It needs to be positive, always positive. It needs to be decreasing on the interval 0 to infinity. And Halimon mentioned that the tangent lines are starting to flatten out. So what I would expect is my graph is going to get closer and closer and closer to 0. So that means f prime has to look something like that. Does anybody recognize that graph? Lewis recognizes it. Lewis, what do you see here?
Oh no, I was gonna ask if it has, if f prime of x has a horizontal asymptote value.
f prime of x will have a horizontal asymptote because I can see that the graph of the natural log of x kind of slowly starts to level off. Stephen?
1 over x.
Okay, does the graph of 1 over x have that behavior? Think about your graph of 1 over x.
Yes. If you increase the x, then
1 over x, so that boomerang graph, that does have this behavior. I can think of another graph. Hello? E to the x. E to the x is increasing from left to right.
Oh,
E to the negative x, okay. There's another graph that you might be thinking about, another parent function. There's another one that has this sort of asymptotic behavior. The graph of 1 over x squared does this too. Remember 1 over x squared was that witch's hat? It's like they're both increasing. So here's the thing, I'm not saying that this is a proof, but based on what we know about how f behaves, we have some evidence that f prime might be 1 over x, might be e to the negative x, or might be 1 over x squared. What I want to do is I want to show you some calculator skills here. So let's take the calculators out. And then you guys are going to play, and that's going to get us all these new derivative rules that are just going to rain down from the sky. Raining down from the sky.
Yay.
Hoorah! Got it? All right. All right, here we go. Why, God, why is it not working? Because I forgot. Oh no, it's been saying that for like a year. The projector lies. All right. No, for real.
So let's say the project.
Don't mess with me.
Useful like an operator. Okay.
All right, here it comes. No, for real. Ugh. Why, God, why? Okay, PC. Stephen, we are filming, right?
yes.
Great. I did all this. I set it up. Oh, no, I didn't. Why? All right, here we go. All right, friends, on your calculator. Aaron, you with me? We're going to graph. Graph. All right, and what I want to graph is the natural log of x. There's the graph of the natural log of x. And I want the calculator to graph for me the derivative of the natural log of x. To make this happen, hit tab. So you get another function. Now we're going to go over to the templates button, the button near the Bible. And because what I want is I want the derivative. You guys know how to get the derivative. It's this guy all the way over here.
Yes.
Okay, so enter. So now here's the thing. You want the derivative with respect to x. What are we taking the derivative of?
F1.
F1 of x. And hit enter. The blue is the graph of the natural log of x that we had originally graphed. The red, it might be hard to see that it's red, but it's red, is the graph of the derivative. Everybody okay? And that is exactly what we sketched by hand. So this should feel good. What I want to do though is I want to make some guesses. So let's hit tab. And I heard somebody say graph, that it looks like the graph of e to the negative x. So we're going to graph e to the negative x. And if the derivative is truly e to the negative x, what we should expect? It's the exact same, uh-oh.
But it's not.
Okay, also I made a mistake because when you graph e to the negative x on here, you need to actually not use the letter E, but you need to use the E button. Okay, clearly not the same graph? Not the same graph. So the derivative of natural log of x cannot be e to the negative x. Could it be 1 over x squared? Is that the match that I'm looking for?
No.
Nope. Nope. Okay, one more. Is that the match I'm looking for?
Whoa.
The black graph is completely, it's called coincidental, it's touching the entire time. that black graph, that really thick black graph, is exactly matching the derivative of the natural log of x. So with this, my conclusion would be that if f of x is the natural log of x, then f prime of x has to be 1 over x. Now, the one thing that the astute student might be paying attention to, you're like, wait a second, but 1 over x also has this guy over here. But the graph of natural log of x doesn't exist over here because of a domain restriction. So we're not going to consider this part. So we can say that if f of x is the natural log of x, f prime of x equals 1 over x, but this is only true for x values greater than 0. All the friends okay? I want you guys to repeat the same process. I want you to sketch. We're going to look at the graphs of sine of x and cosine of x. And I want you guys to start the game, or start the exploration. Looking at the graph of sine of x, what does the derivative have to look like? Same thing for cosine of x. What does the derivative have to look like? You guys should also be able to get e to the x and e to the negative x. Once you've got a sketch, once you think you know it, check on the calculator. I'll give you guys about 10 minutes. Okay. But lunch at some point would probably be appreciated. Okay. Not that one. But basically, but like, I think particle and quotient also and then all these other ones. Thanks. Sketch that graph, then confirm on the calculator. I'm going to move the camera over here. Oh, now you can't see anybody. All right. Nice. Far left in the white is Steven. In the front on the right is Carmen. The guy looking down in the back who's not going to look up for the next 10 minutes is Andrew. And the guy on the right who smiles all the time would be Lewis. Steven, those are some advanced camera moves that I'll train you on.
Huh? Me too. Anyways, that was my story.
I do like legit spin.
Yeah. What is that?
It's a project.
Does it look like that? Does it look nice?
Wait, no. I got like 3. Oh, I did it like E. It's not a V though. Yeah, because that one.
My thing is, I didn't graph like this point. It's like sort of it's like tilted.
Yeah, I think it's interesting.
Take pictures.
how are we doing with the
So, 13, what's her face?
So, which sign of
They
X?
don't know. They're
Someone's gonna, they're gonna watch them.
That's a beautiful graph.
Oh.
And does it happen?
Yeah.
Okay, so perfect. Now this is not a proof, this is just some evidence, right? Like, I know what the graph of sine of X looks like, I can look at like the max, I can tell you about where we're changing from positive to negative, we can talk about concave down, so this guy's decreasing, all the things fit together.
Where's the
So what is the sine of X?
If it's concave down,
Aaron, you okay there?
increasing.
Yes.
I mean, you actually were having a math conversation, so like I wanna give you some credit there. I want to make sure that you guys are having a conversation about the behavior of the graph and what the derivative should look like. And then use that calculator. So derivative of sine of X.
Concave down. It's not even.
Derivative of cosine.
Because I was trying to calculate.
Now right now you may not know why it is the negative sine of X.
So what?
We're not proving things yet.
I'll just
Proofs
copy
are, proofs are coming.
So here's,
Excellent, Aaron. And weren't you supposed to be at the U of H then?
and then this one's concave
Oh, it's
down
3
and
o'clock.
and negative.
Yeah.
I mean decrease.
Alright, now do the
No, it starts
Yeah,
with
now flip
negative.
up and back. Okay, how are we doing with that graph?
We got 40 something.
Never mind.
So I definitely care about you guys having like conversation about how does the graph of sine of X look, how does it behave? What does that mean that the derivative has to look like? I bet you guys look at this and you know exactly what this graph is. This is, check it on the calculator, make sure that you're not lying to yourself. Oh, it's gotta be cosine of X. Check it on the calculator, make sure it matches. Check it on the calculator, make sure it matches.
So it's always
That's the funniest question I heard. Right before we got. Consider
That was terrible.
Alright, looks like everybody has made it on to the back, so if all goes well, your sketches look something like this. And we've concluded that the derivative of sine of X is
cosine of X.
cosine of X. So we've got a new derivative rule for free. The derivative of sine of X is cosine of X, and the derivative of cosine of X
Negative sine of X.
is negative of the sine of X. Okay? Now, we're going to keep in mind, these are not proofs. These are sketches, and then we're confirming our guess on the calculator. Do not go to college next year and be like, oh, we proved it. Look, it's on the calculator. That's not a proof. Proofs are coming. I will rock your world when we hit the proofs. You will know when it has arrived. Keep going. I'm really interested to see what you guys can do in the back.
We're like really, they have to. No, iPad.
Okay, Stephen, please remind me, once we finish up the graphs of e to the x and e to the negative x, we need to take the camera down.
It's gonna give up. Yeah.
Wrong.
Good job, Brett.
I got some glue.
What, my friend?
The same.
Mine is
I knew there was a reason why I was struggling with graphing it.
Oh, yeah.
Oh my god.
I was like, oh, it's gonna go up, but it can't.
He's like-
Because that's going up. But this is going up.
You're putting rules in place that do not exist.
Wait, but why does it?
You gotta look at it in behavior, but you also have to tell me about slope. Right? So like the graph of f of x is increasing.
It's
So
increasing
f
the whole
prime
time.
is, if f of x is increasing, f prime doesn't have to be increasing. If f of x is increasing, f prime has to be
It's
positive.
increasing because it's
Okay,
concave.
this one.
That's why.
There you go, right, because this graph is concave up,
Yes.
f prime is increasing,
And then the horizontal expansion.
right? And as the x values approach infinity, my tangent lines increase faster, which is why this is gonna get steeper.
It stops at. When it reaches zero.
Right, and as you head out towards negative infinity, you have a horizontal asymptote. So the derivative over here, horizontal asymptote. Good. So the derivative of e to the x on the x.
Oh, yeah, because
I don't know. Okay, friends over here, we're doing okay? Okay, so let's have some conversation here, so that we have some video evidence that I do work here. Things that we know about the graph of e to the x. E to the x is increasing, so f prime is positive. F is always increasing, f prime is always positive. Other things we know about f. F is always concave up, so f prime is always increasing. Two other things that you know about f.
I would do the same thing.
Right, as x approaches negative infinity, h of x has a horizontal asymptote, so the derivative has a horizontal asymptote, specifically though at y equals 0. And as x approaches infinity, this graph is increasing faster, 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 faster. So this guy down here, the derivative, is going to become more and more and more positive. And so,
Until you take it though.
okay.
Head slap, head slap.
Oh.
Whoa! Oh, man.
I'm not getting hit yet.
Wait, what's that?
I'm taking your shit.
Please don't. I would not. I would very much not want to.
All right, let's wrap this up because I think I made a promise that there were even more derivative rules coming. All right, Stephen, you got it. Aaron, you okay then? You're looking like you're having a seizure of some sort. All right, so for the benefit of the friends at North Central and East End, we've already gone through, we've done the sketch, and we've discovered that the derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. And everybody's good? So those are like two new rules that you can put in the brain. Derivative of sine of x, cosine of x. Derivative of cosine of x, negative sine of x. Tomorrow when we make the derivative foldable, we're going to put those on there. Now the one that always seems to mess with people's heads is e to the x. The derivative of e to the x is e to the x. And the derivative of e to the negative x is the opposite of e to the negative x. It's the negative of e to the negative x. Because f is decreasing, f prime is negative. Because f is concave up, f prime is increasing. Because this guy has a horizontal asymptote, this guy has a horizontal asymptote at y equals 0. Everything comes in together. So new derivative rules for today. If f of x is natural log of x, you guys told me that f prime of x was what?
Say it again.
Oh, so awkward.
Say it again.
F of x is the natural log of x. F prime of x is
1 over x.
1 over
Where
x.
where x is greater than 0.
Yeah, okay. And if f of x is the sine of x, f prime
Cosine of x.
is cosine of x. And if f of x is the cosine of x, negative sine of x, good. And if f of x is e to the x, f prime, e to the x, easy peasy. And this last one I want to write it in a very specific way. F prime of x is equal to e to the negative, I'm sorry, if f is e to the negative x, then f prime is negative e to the negative x. I'm going to write it this way, and there's a reason, and we'll talk about that later. I'm just going to write this as e to the negative x times negative 1. There's a reason, and that's coming up. All right, so now that we've got these basic derivative rules, now it's time to push. We've had some time to explore. Now let's see what we can do with, for example, problem number 2 on the back here. h of x is equal to sine of x times e to the x, I want you to find, using all your newfound skills, h prime of x and h double prime of x. I'll give you a minute or two to play around with this, see what you can do. Be ready to talk.
Oh, but you gotta use.
Really? Really?
You're just not gonna do this. No.
Yeah, you.
Could it be?
Then who?
Yeah.
And that's the end of the cookie jar song.
We'll have to simplify, could we?
You don't have to simplify, no. All right, h of x equals sine of x times e to the x. So I bet you guys all saw right away, you know exactly what derivative rule you need here. Sine of x. Sine of x times e to the x is product rule. But you might be like, but wait a second, why? Why, if you need me to find h prime, am I going to use the product rule? Because I see sine of x and I see e to the x? That's okay, we're going to have to do it. Product rule says take the derivative of the first, so the derivative of sine of x. Cosine of x times, leave the second one alone. Plus, now we leave the first one alone, times the derivative of the second one. E to the x. Now I'm really interested in h double prime. Steven, you want to take it?
Is it negative sine of x times
Negative sine of x
times e to the x
times e to the x
plus cos of x and e to the x.
plus cosine of x times e to the x. Are you done?
No.
Okay. I want to be really clear. The negative sine of x times e to the x plus cosine of x e to the x is coming from here.
Yeah.
And the product rule here. Right? Because this guy here is the multiplication. It is the product of two functions. So it's the derivative of the first times the second plus the first times the derivative of the second. So Stephen, what you gave us is half of the work. Now I need the derivative of sine of x times e to the x. David, you want to take it?
Yeah.
Go for it.
Plus
Plus?
cosine of x
Okay, so that's the derivative of this guy here.
times e of x
Times e to the x
plus
plus
sine of x
sine of x
times e of x.
times e to the x. All of this came from taking the derivative over here with yet another product rule. You should have 4 products in your second derivative. Everybody doing okay? I would never give that to you as a multiple choice answer because I expect better than that. I would expect you to simplify. Take a look at this. There's some legal simplification that you guys should have in your toolbox. Legal simplification. Lewis sees it. I'm going to wait for some other folks to see this. Legal simplification that can be done. Negative sine of x times e to the x plus cosine of x times e to the x plus cosine of x times e to the x plus sine of x times e to the x. Lewis, give him a little nudge. Or just step. Okay, Lewis saw some simplification. He refuses to share outside of his table. Anybody else see the legal simplification? Celeste, what do you see?
You can add cosine of x times e to the x.
Cosine of x times e to the x. You want to add that with
Cosine of x times
cosine of x e to the x. So now you've got 2 cosine of x e to the x. Any other simplification? There's one more. David, what do you see?
We could basically eliminate sine of x times
Negative sine of x e to the x.
and sine of x.
And positive sine of x times e to the x. So the best final answer here is 2 cosine of x e to the x. That's what I would expect you to be able to pick up on the multiple choice. On free response ILA, no need to reduce. No need to simplify. But on the multiple choice, I won't give you that, I'm going to give you this. All right, let's push a little bit more, shall we?
No, there is no.
All right, see what you guys can do at number 3.
What?
Even the two
No, we should have done like one day.
I know this.
So you use
Palimon, can you do me a favor? Can you read this for me?
Natural log of
Say that one more time. This first part, how would you read it? Natural log of sine of x, right? Is anyone tempted to do multiplication here? Right, this is not natural log times sine of x, this is natural log of sine of x. Maybe if it's helpful, you might even want to think about parentheses there, so you can see it's like natural log of stuff minus sine of e to the x plus e to the power of sine of x.
Oh.
Natural log of sine of x, guess what derivative rule I'm thinking about right now? Natural log of chain rule. That word of is a giveaway. Whenever you see of, you have a composition of functions. And the derivative rule tells me, take the derivative of the mama, leave her baby alone. The derivative of natural log of stuff, derivative of the natural log of stuff is 1 over, be careful, not 1 over x, 1 over the stuff. 1 over sine of x, now times the derivative of the baby, which is cosine of x, minus, now I need to take the derivative of sine of stuff. And the derivative of sine of stuff is cosine of the stuff times the derivative of the stuff. The derivative of e to the x is e to the x plus e to the power of stuff, which is e to the sine of x times cosine of x. There was a chain rule here, and the clue for Andrew and all the friends, as soon as you say that word of, it's chain rule. Natural log of, oh, there's another function. Sine of, there's another function. E to the power of stuff, there's another function. Everybody get it? New derivative rule coming your way. See if you can do it number 4. Oh, I'm tricky. Oh, I'm so tricky.
Is it? You?
No, that's way
God, how are we going to find the derivative of tangent? That's nowhere in my list. Unless somebody has some cleverness. Anybody have any cleverness here? Lewis has got some cleverness. Steven's pulling his hair out because he wants some cleverness. Harmon's got some cleverness. Aaron seems to be on the brink of some cleverness. Aaron, what's your cleverness? What about this tangent? What do you know?
Then equals, is it sine over cos or cos over sine?
Good question. Which one is it?
I think it's sine.
Is tangent sine of x over cosine of x or cosine of x over sine of x?
Because cotangent is cos over x.
Yeah. So I could rewrite, and for all the friends out there, I am not doing any calculus here. Do not show me that this is equal to the derivative. You haven't taken a derivative yet. All you did is you rewrote tangent of x as sine of x over cosine of x. Why, Aaron, would you want to rewrite tangent of x as sine over cosine of x?
We have rules for those.
We have rules for this. How are you going to take the derivative of sine of x over cosine of x? What derivative rule should be screaming at you right now?
The quotient rule.
It's now a quotient rule problem. And so if this is the quotient rule, all right, let's do it. Quotient rule says low d high, polymon it's minus, low d high minus high d low, Low, low. All right, give it to me. Low. Cosine D high.
Cosine.
Minus, so we did low D high minus high.
Sine.
D low.
Negative
Sine.
Negative sine low low.
over
Cosine squared.
I'm going to write it as cosine of x the whole thing squared. No, there is no cancellation. But there is more cleverness here. There's more cleverness here.
Cosine.
One person's got some cleverness here. 2 people. Look at some legal simplification that you can do. There's something really powerful here. Lewis, get us started. What do you see?
2 cos instead of cos times.
Cosine of x times cosine of x is not the same as 2 cos. That would be cosine of x plus cosine of x. Cosine of x times cosine of x means cosine squared. So I've got in the numerator cosine squared of x minus sine of x times negative sine of x minus sine of x times negative sine of x would be plus sine squared of x all over cosine of x, the whole thing squared. That's good, and yet there's more. There's more cleverness that I'm hoping for. Carmen, what do you see?
Cos squared plus sine squared equals 1.
Cosine squared of x plus sine squared of x. This is one of those identities you need to remember from trig. Cosine squared of x plus sine squared of x is 1. This is your Pythagorean identity. No, you.
At least I remember.
Okay.
I was trying to remember that.
So this is 1 over cosine of x, the whole thing squared. And there's more.
That equals something.
That's equal to something.
That equals something.
Not arc stuff. That's next week.
It's
What?
Next week.
what's up?
1 over cosine. It's not the opposite that you're looking for. It's the reciprocal.
Secant.
Secant.
Yeah.
1 over cosine is the secant. So 1 over cosine of x, the whole thing squared, must be
Secant squared of x.
secant squared of x. I will tell you right now, I am going to ask you again to find the derivative of tangent of x, and you are welcome to go through this whole process and figure out, oh, I have to do a quotient rule, oh, I have to use the derivative, oh, I've got to use Pythagorean identity, or you can just lock into your memory banks here that f prime of x is secant squared of x. All right, last one. I'm interested to see what you guys can do with number 5. We're not going to get to the homework check. That's fine. I'm just going to pick it up. Thanks, sir. Thank you, ma'am. Homework over here. Thank you, ma'am. Thank you. All right, homework pile over here. That. Andrew, can you staple? Or do a little origami thing? Oh, Andrew, you got bigger problems now. You need to be tucking your shirt?
Wait, first.
Lewis, untuck your shirt.
No.
I'll take care of that, so you can stop bringing shame to our family.
Wouldn't it be 1 minus sine? Actually be more like 2.
No.
Yes.
Is it the partial?
That's all.
I thought it was the mama.
No.
It's
It should be
cos
cos
squared
of
of
x
x.
times cos of x.
Now.
Alright. F of x is cosine squared.
I mean, I
I'd
think that's
rewrite that. How are we doing on the derivative here? 2 times cosine of x times negative sine of x? The key is that when you see cosine squared of x, to really think it's cosine of x squared. And so then it's a chain rule where you say, oh, I've got stuff squared. 2 times the stuff times the derivative of the stuff, so you'd have negative 2 sine of x cosine of x. To figure out the rest, you'd have to evaluate f at pi over 4. The cosine of pi over 4, you guys know, is square root of 2 over 2. Squared is going to be a half. This guy here, f prime of pi over 4, is negative 2 sine pi over 4, cosine pi over 4. So we get negative 2 times square root of 2 over 2 times square root of 2 over 2, which I think is negative 1. Equation of the tangent line then is going to be negative 1 x minus pi over 4 plus a half. I know we went way fast. And so f of 2 is going to be approximately negative 1, 2 minus pi over 4 plus a half. All right, I'll see you guys later.
You're right.